We've talked a bit already about the basics of encryption. We've shown a few different very simple methods. I hope it's clear that they've been not good methods to actually keep your sensitive information or data. The goal has been to learn from them, right? To look at how you could create programs that would do that and to start to get the idea of encryption, not to actually think that it's secure. Instead of just saying that, I thought, well, why don't we make some programs that will prove that these methods are not good? Here we have a Caesar cipher. It's not the program I made before because I re-imaged my machine and I didn't, apparently I forgot to grab my presentations folder, my demonstrations folder, but it's fine. So I just rewrote it. It's cool. I didn't feel like going back to the old video and pausing and typing it all out. Because I know how to do it. I know different ways how to do it. The logic's not too hard once you start to get used to programming and stuff. So I just made a new one, and if it's different, that's fine, because exposure is good for you, and seeing a different way to do it is fine too. So it re-emphasizes too that there's lots of ways to write programs. So here's another Caesar cipher. So what are we looking at? At the top, I've declared my variables. I have a clear text here, so this is the unencrypted original message that they'll input. So I'm asking for the user's input, and I'm converting it to lower because I didn't want to deal with capitals. I just didn't feel like writing more because that's not the main point of this. The main point is breaking it. We have a string here called valid letters that has A through Z and the spacebar in there, which, keep in mind, is a character according to the computer. And I'll talk about the point of this in a moment. We have the shift value, which the user can input, and I have it being converted into an integer just to make sure that it goes in as an integer. Of course, if they type in like the word 2 or the word 3 instead of the Arabic numeral, yeah, that'll cause some trouble, but it's fine. I'm assuming that people aren't going to do that. Now I have two more variables. I have new string, and it equals nothing. It is something, actually. It's a string. It's just an empty string. So basically, I'm just telling the computer, like, hey, store some memory space for this. And I've got another one, ciphertext, and this is an empty list. We haven't really talked about lists yet, but we will. And it's fine that I'm using one already. It's fine. Basically, a list is just a collection of things. It could be a collection of strings or of integers or of strings and integers, etc. It's once again just another space in the memory that I'm saying, like, I'm going to put stuff here, be ready. So now I've got some for loops. I've got for char in clear text, and so this is just saying for each character in the user's input, if that character is in the valid letters, then add that character to the new string. You might say, well, this is repetitive, why did I do that? Well, basically what it's doing, it's making sure that nothing sneaks through. I didn't feel like dealing with punctuation either, not just capitals, but I didn't feel like dealing with punctuation or any other special symbols, just the basic English alphabet all in lowercase. So if they sneak in any like weird symbols that I didn't expect, it's not going to be added to the string, which means it's not going to try to convert it into the cipher, and it won't screw things up. Hopefully, that's all this is. This is just a safeguard using this as like what's acceptable, what it will try to convert. Then we have another for loop, and this is the part that actually converts it. So it's converting each one of the characters that they, well, not that they entered, but that it kept, that it added to here, that it felt were approved. It's taking each one of those and it's converting it to a number, and then it's adding the shift value to that number, and then here, basically, it's going to convert it back. So it shifted the value, then it's going to convert it back, and of course that depends on if it's in the right values, which we talked a little bit about some of that earlier on. You know, what values the different letters convert to. So if it's too high, it's going to do it a little differently. If it's within the right range, then we're good. It's going to convert that into char. So this is taking the shifted values and converting them back to the regular values, similar to how we did it in the other program. Should be pretty similar. If you're a little confused on this, then go back and watch that other video, because I don't want to eat up a whole bunch of extra time by explaining it when most of you probably already remember it from the previous video. So Then we're going to print the clear text, just so that way we have the reference. And then we're going to print the ciphertext with a little cute message of this is your super secure, which we know it's not, encrypted message. So if we try it, secret message will be tacos are great. Just keeping with my, ooh, yeah, we'll try this out because it should throw those out. But just keeping with my theme of tacos. So enter shift value, let's go with 5. And we move this up. Tacos are great, shift value of 5. Tacos are great is the original, which I should have maybe labeled that, but it's okay. And then the super secure encrypted message, here we go. Tacos are great, with no punctuation, because they aren't in this, so it just threw them away. And if we do the counting, let's see, so T, so 1, 2, 3, 4, 5, it worked. And if we're a little unsure, let's see, oh, that's the latest, that's the first one of the alphabet, but we can make sure it wraps around too. So if I play it again, maybe zombies like tacos, and we'll do 5 again, and so the Z becomes an E. So here's Z, 1, 2, 3, 4, 5. It works. So the wraparound works just fine too. No problems. It works. So now I was saying that this is not secure, and how can we prove that? Well, if we want to prove that, we can basically just reinsert into the shift value, right? So let's not print the clear text. Let's instead like add a new line, and we're gonna say breaking our super secure encrypted message, and now we're going to I wish I had made that a function, because if I had made that a function, then I could just throw in there, like, the different shift values. That's what I'm going to do. That is what I'm going to do. Let's make this def. No. We'll make a function, def, decrypt, and we'll put shift in here. We'll basically just copy and paste this. For char in new string, but it's not going to be new string anymore. It's going to be for char in the ciphertext, right? Because we're going to try to crack the ciphertext. XORed of char, shift. So when we're shifting, when we're encrypting, we're adding to it. But if the shift value was 5 when we were encrypted and we added 5, now we need to do the opposite. We need to subtract. So this will be minus shift. Yeah, I think that's it. I think that's all we need to do. And then I think we just we print it. We print it right here. Prints. Ooh, but that's appending to ciphertext. No, we don't want to append to ciphertext. We need a new one. We need no. I want it to be contained inside of this because I don't want it to keep adding it each time. Attempt. Because a lot of them aren't going to work. Attempt, so make that an empty string, and then, oh, it's not going to like that for append. Attempt, that's okay. Plus equals, will that be fine? I think so. Plus equals attempt. Let's try it. So zombies like tacos. Enter shift value 5. Well, it's close. Zombies. So it chose to make that a capital A with an accent instead of the Z. So why did it do that? Let's take a look. So I'm gonna make a new file real fast. New Python file. Test. I already have a test. Test. All right. So we've got. What this is the char, so we need to figure out what the ord of this is. So print ord, yeah, do that. What do you mean A is not? Oh, my mistake. 192. So if we go back to Caesar break, 192, 96 plus X. Is that too high? But shouldn't that have moduloed? We shouldn't be getting all the way up to 192. It should be a Z. So what would Z equal? It should be a lowercase z. 122. 122. Why is it not if it's less than 122? What if it's less than 123? Zombies like tacos. 5. No, it's still zombies like tacos. So it should be taking this. It should be an E. And it should be going... What is A? 97. 97. Print. Char. 96. Name char is not char. That thingy. I see what the issue is. So 101 minus 5. 101 minus 5 is giving us 96, which is below this, and so then it's adding 96 to 96. If it's below 96, what is Z? Run this. 122. So let's do else 122. So 147. Wait. Am I? Yeah. Oh my god. Okay. This just needs to be 26 because that's. Yeah. This. Okay. 26 letters plus whatever X is modulo 122. Oh man, that's not that hard. Okay. Alright, so that works. Right, so even if we don't know what the decrypt value is, it doesn't matter, because we can just decrypt all of them. So we can just say while I is less than 26, do all this, and all of this can be in there. Alright, and print the attempts. And then at the very end, we'll just add I plus equals 1. And at the start, we're going to say I equals 0. So basically what it's going to do is it's just going to run this over and over and over again until it's done all 26. And we'll say here that shift equals, I guess we'll say that shift equals 0 here as well. And then here we're going to say shift plus equals 1. And if I got this right, it should run through 26 attempts, and no matter what the shift value is, it should break it on one of them. So hopefully this makes sense. We've written a function, decrypt function. We were able to do it for 1, right? We did 1, and once I made sure that that worked, then I turned it into a while loop that would do this 26 times. So I starts at 0, so it's going to activate. Once it does it once, it's going to do it. It's going to add 1 to it, add 1 to the shift. It's going to do it again. So now I is 1 because it's still in this while loop, and we added 1 to while. It's going to run this whole thing again. Shift is now 1. I is going to become 2 after trying it. Shift's going to become 2 after trying it, so it's going to do it again. I is 2. It's still below 26, so it's going to do it again. I becomes 3. Shift becomes 3. It's going to do it again. I becomes 4. Shift becomes 4. So on until 26. So let's try it. So zombies, shift value, I don't know, 20. My fault. I forgot to delete the value for that. Try again. Zombies, 20. Alright. So now we just read through this whole list until we can find it. There it is. Zombies. Now if we wanted to, we could even tell it to print what shift value this was too. So we could say like key of, I'm going to put a comma there because it's a different type. and this is going to be shift, and then the attempt. And so now it should say key of each one, and then the actual thing. So let's try it again. So message will be zebras, and the shift value is going to be 3. And if we look in here, oh, there it is, key of 3, zebras. Let's try it again. Run the Caesar code. If zombies, quickly, fax, judge, pats. Shift value of 24. Right? Key of 24, if zombies, quickly, fax, judge, pat. There we go. So this is really easy to break because you can make the computer do it for you and then just figure out where you can actually read the line. So not very good. Now, there are other methods, some of which I think I've mentioned, and they're not much better, but they're definitely better than this. Thanks for watching, and I hope you'll join me for the next one.